Right, here we have a table showing the distances between 6 towns, A, B, C, D, E and F. And what we need to do is to use Prim's algorithm to find a minimum spanning tree. Now, a tree is a connected graph with no cycles. So if we think of this network here, there's no cycles. A cycle would exist if there was an extra arc like that. So now there's a cycle going around like this. So that's what a tree is. A tree is a connected graph with no cycles. So if we got rid of that. And a minimum spanning tree is a tree such that the total length of its arcs is as small as possible. So we want the total length of the tree that connects these towns, the total length, to be as small as possible. So Prim's algorithm for a distance matrix or table says we need to choose any vertex to start the tree. Well, they told us to start at A, and then it says delete the row in the matrix for the chosen vertex. So we need to delete row A. We now need to number the column in the matrix for the chosen vertex. So A is going to be 1. We now need to put a ring around the lowest undeleted entry in the numbered column. The lowest undeleted entry in column 1 is clearly 70. So let's put a ring around the number 70. The ringed entry becomes the next arc to be added to the tree. So the first arc is AD, because we're from A to D is the smallest number. Now we go through these steps again. We delete the row in the matrix for the chosen vertex. Well, the row is D. We number the column in the matrix for that vertex, so that's 2. We need to put a ring round the lowest undeleted entry in the numbered column. Actually, that's not right. We need to put a ring round the lowest undeleted entry in the numbered columns. So don't just look at the one you've just done. Look at all the numbered columns and find the smallest number. Well, the smallest number is 95. So we put a ring round 95, and AE becomes the next arc to be added to the minimum spanning tree. We now delete the row in the matrix for row E and number E3. We now put a ring around the lowest undeleted entry in the numbered columns. The lowest undeleted entry in the numbered columns is 125. So DB is the next arc to be added to the minimum spanning tree. We delete the row for B, make B number 4, and now put a ring around the lowest undeleted entry in the numbered columns. So the numbered columns are 1, 4, 2 and 3. What's the lowest number in 1, 4, 2 or 3? It's 150. So C is now number 5. Cross out C there. The lowest undeleted entry in the numbered columns is now 155. And so CF is the last arc to be added. Did you notice that I missed out DC? So, we now need to draw your tree using the vertices given in diagram 1 in the answer book. Well, in the answer book, they've given you the diagram that looks a little bit like this: A, B, C, D, E and F. So AD is there, AE is there, DB is there, DC is there. Now CF, personally, I hate it if you drew it like this, because it would then, in my mind, have 3 more crossing points. But the answer book, the mark scheme, allows you to draw a line like that. Personally, I prefer to draw it like that. Now, what's the weight of the tree? Well, the weight is the numbers I've circled all added up. So 70, 95, 155, 125 and 150. And that makes 595 kilometres. Don't forget the units, just in case the mark scheme is being a bit mean to you.